Welcome, my dear students, to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 3, Normal Distribution, brought to you by Vitan Sir. Now, at the beginning of this chapter, let's just revise what is a continuous random variable. The reason for this is that in the first chapter of the second part, we studied about the probability. In the second chapter, we studied that the random variables have two types, that is discrete and continuous. And in second chapter, we studied about the discrete random variable, its probability distributions, and the binomial distribution. In this chapter, we are going to start with the continuous random variable. So let's see what it is. If a random variable x can assume any value in the real set R or within any interval of real set R, then it is called a continuous random variable. Now here the main word which you need to pay attention to is the interval. We know that a discrete variable or a discrete random variable only assumes singular values. For example, heads and tails, then the number of heads would be 0, 1, 2, 3, something like that. But it will never be 2.3 or 1.2 or something like that. So we only got definite values in the discrete random variable, but because this is a continuous random variable, we can't get any definite values, rather we get intervals. Getting my point here? We get the intervals, that is all the possible values between 1 and 2. Now, if you want to list out these values, they are infinite. So we can't list them out as singular values, and therefore we'll depict them using intervals. I have explained here graphically. Let's assume that this straight line is a set of all the values of R, and there are 2 points on this line named A and B. So each and every possible value between these 2 points A and B, I will call it x. So then that x becomes a continuous random variable. I hope you guys got it properly. Let's move forward and understand it still better. X can be depicted as x is the value between a and b. So then it's a normal variable. So the function which calculates probability for this particular variable, which is assuming a value between the intervals, we call that function the probability density function of a continuous random variable. So here the function or the formula, I hope you guys remember the formula used in binomial probability distribution, ncx, p raised to x, q raised to n minus x. That was the probability density function of a discrete random variable for or a binomial variable. This time we are talking about the continuous random variable. So the probability density function or the function which calculates the probability for the given continuous random variable, we call it the probability density function of a continuous random variable. So keep this probability density function in your minds, because we have already studied one function before. This time also we are going to study another function, and in college level also you will be studying many probability distributions, and the formulas for calculating those distributions will be called probability density function. So remember this thing properly. Now this function should satisfy two rules. There are two rules which a function should satisfy. Do you remember in the second chapter we said that if it's a discrete probability distribution, then there should be two rules? Yes, we are going to state the exact same rules, but with respect to the continuous distribution. So if it's a continuous distribution, the probability that the value of random variable lies between the specific intervals is non-negative. that is it should be either 0 or positive. So it's same thing that the probability should not be negative, it should be either 0 or a positive value. And the second thing that the total probability that the random variable assumes any value within the specified interval is 1. Okay, so the random variable assumes any value within the specified interval, so the total probability of all those things should be 1. And if I want to state it in symbols, the px should be greater than or equal to 0, that is the probability, and the total of px should be 1. These are the same two rules according to the second chapter also, and also the first chapter we applied the same rules. So these two rules don't change for any probabilities. No matter what the distribution, these two rules are constant. Probability should be positive or 0 and total should be 1. You are not going to change this rule for any distribution in future which you may study, because these are the fundamentals of probability. Okay, so uh, print them in your minds, okay, properly. Now, something which you need to remember that because x is a continuous random variable and because it assumes infinite values within the two intervals, and therefore if we say that the x assumes any single value from that interval, only single value, then it is always 0. Reason? Because total of all the values, total of all the probabilities is 1, and we have infinite options. If we take single values, we have infinite values between the two intervals. So if you have taken some interest in maths, 1 divided by infinity is 0. Okay, what I am trying to tell here is that if I divide the total probability 1 among the infinite definite values of x, then the individual values of probability of x of a single value will be 0. We are talking about the continuous variable here, that's why. In discrete variable it is not the case, but because in the continuous variable the single values are infinite, so the probability of a single value of x is 0. So what happens because of this, that when we write the probability of p a is less than x is less than b, then it is not different from a less than equal to x is less than equal to b. Okay, because whether x is equal to a or not equal to a doesn't make that much of a difference, because x equal to a probability is 0, x equal to b probability is also 0. So whether we write it as less than or less than equal to, it does not make a difference. So when what it helps us in doing, that whenever we are writing down these equations, it's okay whether we write less than or less than equal to, or whether in the question less than equal to is asked and we just use it as a less than sign, or whether in the question less than is asked and we use less than equal to sign, it will not make a difference. So you will not be confused that okay, they have asked for less than, but I only know how to calculate less than equal to, so what to do? Don't worry, doesn't matter. The answer for both of them will be equal. Why? Because the single definite value probability for x is 0. So it doesn't matter. It doesn't make a difference whether you write less than sign or less than equal to sign. Only for this particular distribution, not for everything else. I am not giving a general statement. I am only talking about this particular distribution. So whether you write less than or less than equal to in the calculation doesn't matter. Okay, that's the final essential point of the story. So even if you have not understood actually the concept, just remember, whether you write a less than or less than equal to sign, it doesn't matter. If you have understood, well and good. If not, just remember those last part. Okay, moving on. Main thing for this chapter, the probability density function. Now, the probability density function is the function or the formula for probability where x is a continuous random variable with mean mu and standard deviation sigma. Okay, so remember that x is a variable, mu is depicted as mean. Okay, so the symbol for mean is mu and the symbol for standard deviation is sigma. Now this is called sigma. So that's why I have been teaching you guys to call that totaling sign as summation, because we are going to call this sign as sigma, and it's a long formula. Fx is equal to 1 upon sigma under root 2 pi into e raised to negative 1 upon 2 into x minus mu upon sigma the whole square, where x is lies between negative infinity and positive infinity, mu the mean lies between negative infinity and positive infinity, and the value of sigma the standard deviation lies between 0 and infinity. Now if you are worrying about the formula here, don't worry, because in my next tutorial I will explain actually how we are going to use this formula. Not in this tutorial, this is just a basic introduction. The practical sums and all those will start from the next tutorial, so I'm not going very deep into this formula right now. I'll be going it in the next tutorial. Just remember the pi is 3.1416 and the value of e, which is also a constant, is 2.7183. Okay. X is called the normal random variable, and fx is called the probability density function of a normal random variable, and therefore the distribution of this variable is called the normal distribution and is denoted as n bracket mu sigma square. Now remember that in the second chapter we talk about the parameters. Okay, so in the binomial distribution the parameters were n and p. N was the number of trials, p was the probability of success. So in this distribution, if you are asked what are the parameters are mu and sigma square. Okay, because this distribution is denoted as n for normal distribution and mu sigma square. So mu and sigma square are the list of parameters for this distribution. That means if you want to calculate probability for this distribution, you must need the values of mu and sigma square. Now, when we draw a curve by considering the different values of x and its respective probabilities fx, it is depicted as above. That means when we draw a curve using the value of variable and its probabilities, we get a normal curve. A curve, the name of the curve is normal, and if you want to try it out in the future, try it out, but right now I'm just writing it down as it is. This is the curve which we get by depicting the values of x and fx. Okay. Now in this curve, the leftmost limit is the negative infinity, because the value of x lies between negative infinity and positive infinity. So the rightmost value will be the positive infinity. Now, mean is the average of the whole distribution. Therefore, mean always lies at the center, because from this curve you can see this is a symmetric distribution. This is a bell-shaped curve, and therefore the mean will lie at the exact center. So that center point divides the whole curve into two parts, and the whole curve is depicted using the values of x and the frequencies, that is probability values. This is a bell-shaped curve, and from that we can say that this is a symmetric distribution. So this was the introduction for the normal distribution, the continuous random variable, the normal random variable, and the normal distribution. In my next tutorial, I will start with some further theories and then some characteristics of the normal distribution and such. Sums will be taught later on. I hope you guys understood these concepts properly. In case of any doubts, you can contact me, and I will see you next time. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.